The National Electrical Code, or NEC, does not specify a length limit for conduit installed inside a residential kitchen cabinet. However, the NEC provides general guidelines for installing electrical wiring in conduits. These guidelines ensure safety and code compliance. Let's explore some key aspects to consider when using conduit in your kitchen cabinet. Firstly, consider NEC Section 352.4b, which mandates that conduits must be installed in a workmanlike manner and be securely supported. This means the conduit should be neatly and professionally installed, and it should be firmly attached to the cabinet structure to prevent movement or strain. Secondly, consider NEC Section 352.4c, which requires that conduits must be installed without sharp edges or burrs and be free from defects that could damage the wires. Sharp edges or burrs can compromise the insulation of the wires, leading to potential short circuits or electrical hazards. Thirdly, consider NEC Section 352.4f, which stipulates that conduits must be installed with a minimum of 1/4 inch of clearance from other objects. This clearance helps prevent overheating and ensures that the conduit and wiring are not subjected to unnecessary stress or abrasion. Now, let's address the specifics of using a 6-foot length of conduit with 12-gauge wire in your kitchen cabinet for a 20-amp circuit. Several factors need to be evaluated to ensure this setup is safe and compliant. The length of the conduit run being 6 feet is an important factor. According to NEC Table 310.15b16, this length is within the allowable limits for a 20-amp circuit, so it is good. The use of 12-gauge wire is appropriate for a 20-amp circuit. 12-gauge wire is rated to handle the current demands of a 20-amp circuit, provided it is installed and protected correctly. The conduit must be installed in a workmanlike manner and be securely supported as previously described. A proper installation is crucial for the longevity and safety of the electrical system. The conduit must be installed without sharp edges or burrs and be free from defects that could damage the wires. This ensures the integrity of the wiring insulation and prevents potential hazards. The conduit must be installed with a minimum of 1/4 inch of clearance from other objects to prevent overheating and ensure proper ventilation. Based on these considerations, using 6 feet of conduit containing 12-gauge wire in your situation is generally safe, provided all the aforementioned conditions are met. However, it is paramount to ensure that the conduit is installed correctly and that the wires are securely terminated. Proper termination involves making sure the wire connections are tight and secure, using appropriate connectors and fittings. Always double-check your work or have it checked to make sure that everything is correct to prevent any electrical problems later on. When installing electrical wiring in conduits, it's essential to follow all applicable codes and regulations to ensure safety and prevent electrical hazards. If you are unsure about any aspect of the installation, consult with a qualified electrician to ensure that the work is performed correctly and safely. Let's delve deeper into the NEC sections that are relevant to conduit installations, offering more context and practical advice. Section 352 covers the requirements for rigid polyvinyl chloride conduit, commonly known as PVC conduit. PVC conduit is often used in residential applications due to its durability, resistance to corrosion, and ease of installation. Understanding the requirements outlined in Section 352 is crucial for ensuring a safe and compliant installation. One key aspect of Section 352 is the requirements for supporting PVC conduit. The NEC specifies the maximum spacing between supports for PVC conduit based on the conduit size. Proper support prevents sagging or displacement of the conduit, which can lead to stress in the wiring and potential damage. Always consult the NEC to determine the appropriate support spacing for your specific conduit size and application. Another important consideration is the bending radius for PVC conduit. The NEC specifies the minimum bending radius to prevent damage to the conduit and the enclosed wiring. Using the correct bending radius ensures that the conduit maintains its structural integrity and that the wires can be easily pulled through. When bending PVC conduit, use a conduit bender designed for this purpose and follow the manufacturer's instructions carefully. Section 310 of the NEC covers the requirements for conductors for general wiring. This section provides information on conductor types, sizes, and ampacity ratings. Understanding the requirements in Section 310 is essential for selecting the appropriate conductors for your electrical installation. One key aspect of Section 310 is the ampacity ratings of conductors. Ampacity is the maximum current, measured in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables that list the ampacity ratings for various conductor types and sizes based on their insulation type and ambient temperature. When selecting conductors for your installation, be sure to choose conductors with an ampacity rating that is sufficient for the intended load. Another important consideration is the dirting of conductors. Dirting is the reduction of a conductor's ampacity rating due to factors such as high ambient temperature or the presence of multiple conductors in a raceway or cable. The NEC provides guidelines for dirting conductors in various situations. It is important to apply the appropriate dirting factors to ensure that the conductors are not overloaded, which can lead to overheating and potential fire hazards. Section 314 of the NEC covers the requirements for outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. These components are essential for making connections, protecting wiring, and providing access for maintenance and repairs. Understanding the requirements in Section 314 is crucial for ensuring a safe and compliant installation. One key aspect of Section 314 is the requirements for box fill. Box fill refers to the maximum number of conductors, devices, and fittings that can be installed in a box. The NEC provides formulas and tables for calculating box fill based on the size and type of box and the size and number of conductors. It is important to ensure that boxes are not overfilled, as this can lead to overheating and damage to the wiring. Another important consideration is the requirements for securing and supporting boxes. The NEC specifies the methods and materials that must be used to secure and support boxes to ensure that they are properly mounted and protected. Boxes must be securely fastened to the building structure and supported in a way that prevents them from being damaged or displaced. In addition to these specific sections of the NEC, there are other general requirements that apply to all electrical installations. These requirements are intended to ensure safety and prevent electrical hazards. One important general requirement is the proper grounding of electrical systems. Grounding is the connection of electrical equipment and circuits to the earth to provide a low impedance path for fault current. Proper grounding helps to protect against electric shock and reduce the risk of fire. The NEC provides detailed requirements for grounding electrical systems, including the types of grounding electrodes that must be used and the methods for connecting them. Another important general requirement is the use of ground fault circuit interrupters, commonly known as GFCIs, in certain locations. GFCIs are designed to detect ground faults, which are unintended electrical paths to ground, and to quickly interrupt the circuit to prevent electric shock. The NEC requires GFCIs to be installed in locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Understanding and complying with these general requirements is essential for ensuring the safety of your electrical installation. When planning and executing your electrical installation, it is also important to consider the specific requirements of your local electrical code. Local electrical codes may have additional requirements or restrictions that are not included in the NEC. It is always a good idea to check with your local building department or a qualified electrician to ensure that your installation complies with all applicable codes and regulations. Remember, electrical work can be dangerous, and it is always best to err on the side of caution. If you are unsure about any aspect of your electrical installation, consult with a qualified electrician to ensure that the work is performed correctly and safely. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. Hiring a qualified electrician can help to protect you, your family, and your property from electrical hazards. In summary, while the NEC doesn't specify a length limit for conduit inside kitchen cabinets, adhering to general guidelines is critical. Proper installation practices, including secure support, absence of sharp edges, and adequate clearance, are essential. Using the correct wire gauge, following ampacity ratings, and considering derriting factors are also crucial for safety. Remember to consult the NEC local codes and a qualified electrician for any questions or concerns. By following these guidelines, you can ensure a safe and compliant electrical installation in your kitchen. When dealing with electrical installations in confined spaces such as kitchen cabinets, it is important to pay close attention to ventilation and heat dissipation. Electrical components such as receptacles and wiring can generate heat during normal operation. In enclosed spaces, this heat can build up, potentially leading to overheating and reduced performance. To mitigate this risk, ensure that there is adequate ventilation around electrical components. This can be achieved by providing openings in the cabinet or by using ventilation fans to circulate air. Additionally, avoid overcrowding electrical components in confined spaces, as this can restrict airflow and increase the risk of overheating. When selecting electrical components for use in kitchen cabinets, consider components that are designed for high-temperature environments. These components are typically constructed with materials that can withstand high temperatures without degrading or failing. Look for components that are specifically rated for use in enclosed spaces or high-temperature applications. Furthermore, it is important to regularly inspect electrical installations in kitchen cabinets for signs of overheating or damage. Look for discoloration, melting, or burning of wiring or components. If you notice any of these signs, immediately disconnect the power and consult with a qualified electrician to investigate and repair the problem. Neglecting these signs can lead to serious electrical hazards, including fire. In addition to ventilation and heat dissipation, it is also important to consider the potential for moisture in kitchen cabinets. Kitchens are often humid environments, and moisture can accumulate in cabinets, potentially damaging electrical components and creating a shock hazard. To protect against moisture, use moisture-resistant or waterproof electrical components in kitchen cabinets. These components are designed to withstand exposure to moisture without corroding or failing. Additionally, ensure that all wiring and connections are properly sealed to prevent moisture from entering. Consider using sealant and waterproof boxes and conduit to ensure the safety of your electrical installation. When installing electrical wiring in kitchen cabinets, pay close attention to the routing of the wiring. Avoid running wiring near sources of heat or moisture, such as stoves, dishwashers, and sinks. Keep wiring away from sharp edges or abrasive surfaces that could damage the insulation. Use clamps and supports to secure wiring in place and prevent it from rubbing against cabinet surfaces. Proper routing of wiring helps to protect it from damage and reduces the risk of electrical hazards. Another important consideration when working with electrical installations in kitchen cabinets is the accessibility of the wiring and components. The NEC requires that electrical wiring and components be accessible for inspection, maintenance, and repair. Ensure that you can easily access the wiring and components in your kitchen cabinets without having to remove or disassemble the cabinets. This may involve installing access panels or using removable shelves. Proper accessibility makes it easier to troubleshoot and repair electrical problems and ensures that the installation can be maintained safely over time. When making electrical connections in kitchen cabinets, use only approved connectors and fittings. These connectors and fittings are designed to provide a secure and reliable electrical connection. Avoid using makeshift or improper connectors, as these can lead to loose connections, overheating, and electrical hazards. Follow the manufacturer's instructions when installing connectors and fittings and ensure that all connections are properly tightened. Proper connections are essential for ensuring the safety and reliability of your electrical installation. In addition to the technical aspects of electrical installations in kitchen cabinets, it is also important to consider the aesthetic aspects. Electrical wiring and components can be unsightly, and it is important to conceal them as much as possible without compromising safety or accessibility. Use wire management techniques such as wire ties and cable trays to keep wiring organized and out of sight. Consider using recessed lighting and outlets to minimize the visual impact of electrical components. Proper wire management and concealment can enhance the overall appearance of your kitchen while maintaining a safe and functional electrical system. Before starting any electrical work in your kitchen cabinet, be sure to disconnect the power to the circuits you will be working on. This is essential for preventing electric shock. Use a voltage tester to verify that the power is off before touching any wires or components. Always treat electrical circuits as if they are live, even when you think the power is off. Taking these precautions can help to prevent serious injury or death. After completing your electrical work, thoroughly inspect the installation to ensure that everything is properly connected and secured. Check for any loose wires, exposed connections, or damaged components. Use a circuit tester to verify that the circuit is functioning properly and that there are no ground faults. If you find any problems, correct them immediately. A thorough inspection is essential for ensuring the safety and reliability of your electrical installation. Finally, remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes and revisions to ensure that your electrical installations are always in compliance. Consult with a qualified electrician or electrical inspector to learn about any new requirements that may affect your work. Staying informed is essential for maintaining a safe and code-compliant electrical system. Let's address some frequently asked questions related to electrical installations in kitchen cabinets. One common question is whether it is permissible to run Romex, also known as non-metallic sheath cable, inside kitchen cabinets. The answer is yes. Romex can be used inside kitchen cabinets provided that it is properly protected from physical damage. The NEC allows Romex to be run through bored holes in wood framing members or through conduit for protection. However, it is important to ensure that the Romex is not exposed to sharp edges or abrasive surfaces that could damage the sheathing. Another common question is whether it is necessary to use conduit for all electrical wiring in kitchen cabinets. The answer is no. Conduit is not always required for electrical wiring in kitchen cabinets. However, conduit is often recommended for added protection, especially in areas where the wiring is exposed to physical damage or moisture. Conduit can also provide a more professional and aesthetically pleasing appearance. Ultimately, the decision of whether or not to use conduit depends on the specific requirements of your installation and your personal preferences. A third common question is how to determine the correct size of conduit to use for a particular wiring application. The answer is to consult the NEC and use the appropriate conduit fill calculations. The NEC specifies the maximum number of conductors that can be installed in a particular size of conduit based on the size and type of conductors. It is important to perform these calculations carefully to ensure that the conduit is not overfilled, as this can lead to overheating and damage to the wiring. Let's explore some best practices for electrical safety in kitchen cabinets. Firstly, always use tamper-resistant receptacles in kitchen cabinets, especially if there are young children in the home. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots, reducing the risk of electric shock. Secondly, install arc fault circuit interrupters, or SIs, on circuits that serve kitchen cabinets. SIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. SIs can quickly interrupt the circuit to prevent a fire from starting. Thirdly, label all electrical circuits in your kitchen cabinet clearly and accurately. This makes it easier to identify the correct circuit when troubleshooting or performing maintenance. Use a permanent marker to label the circuits on the circuit breaker panel and on the wiring in the cabinet. Let's delve into the topic of electrical inspections for kitchen cabinets. Electrical inspections are an important part of ensuring the safety and compliance of your electrical installations. A qualified electrical inspector will examine your wiring, components, and connections to ensure that they meet all applicable codes and regulations. An electrical inspection can help to identify potential hazards and prevent electrical problems from occurring. It is recommended to have your electrical installations inspected periodically, especially after making significant changes or additions. Let's consider the use of smart home technology in kitchen cabinets. Smart home technology can enhance the convenience and functionality of your kitchen cabinets. For example, you can install smart lighting that can be controlled remotely or automatically. You can also install smart outlets that can be used to monitor energy consumption and control appliances. When installing smart home technology in your kitchen cabinets, be sure to follow all applicable codes and regulations and consult with a qualified electrician if needed. Finally, let's discuss the importance of ongoing maintenance for electrical installations in kitchen cabinets. Electrical installations require regular maintenance to ensure that they continue to operate safely and reliably. Inspect your wiring, components, and connections periodically for signs of wear, damage, or corrosion. Tighten any loose connections and replace any damaged components. Clean the wiring and components to remove dust and debris. By performing regular maintenance, you can extend the life of your electrical installations and prevent electrical problems from occurring. Remember, electrical safety is paramount. Take the time to learn about the codes, regulations, and best practices for electrical installations in kitchen cabinets. Consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure a safe and code-compliant electrical system in your kitchen. When working with electrical systems, always prioritize safety and exercise caution. Do not hesitate to seek professional assistance when needed. A safe and well-maintained electrical system is essential for the comfort, convenience, and safety of your home.